please give him a warm round of applause both now and after, because what he does makes what we do possible. Thank you.
Thanks. I'm Jeff GARZIK, Bitcoin core developer and CEO of Dunvegan Space. We're going to cover 3 topics today. We're going to be covering Bitcoin Core itself. We're going to be announcing at BitPay a new instant secure transaction protocol. And can we go back? Back. And we'll be talking about outer space. So, Bitcoin Core. There are a lot of new features coming out in Bitcoin Core 0.10. That's the upcoming release. Our typical release cycles, we try to have about 4 releases a year, and it's time-based rather than feature-driven. So right now, we have the release candidate for 0.10 out for testing, and I encourage everyone to download and try to test that. One of the very key features is called a headers first download. Now this is going to solve a major pain point for anyone running the full blockchain. One of the major complaints is the time to sync with the network and download new blocks. In the currently released Bitcoin Core, sometimes that can take 6 hours, 12 hours, depending on your network connection, what other peers you're talking to, etc. And this feature is something that has always been enabled since the time when Satoshi wrote it, but like many features in Bitcoin, it takes time to develop on top of those and enable those features at the user level. So what does headers first sync do? Headers first downloads all the block headers. That's 300,000 plus 80-byte segments. And so that's really, really fast. That's about 27 megabytes of data versus 20 plus gigabytes of data. And once you download that, you already know the entire blockchain and you know the secure longest chain. You've proved the proof of work. So then it's downloading the blocks itself from multiple peers. Previously, you were just downloading from one peer, and if you got really bad luck, then that peer might be slow, et cetera. It was nowhere near the quality of, for example, a BitTorrent download. So with the headers first download, we can now talk to peers in parallel, download blocks in parallel, and because this is integrated into the Bitcoin client, it's actually now faster than a BitTorrent download. Because when you're downloading the blocks, you're also checking them, verifying them, and syncing them into the database in parallel as well. So, but finally, and more importantly, the headers first sync is more secure than the current Bitcoin block sync, because that headers first enables you to prove the proof of work all the way to the longest chain, rather than just trusting each peer as to which chain is the longest, and then finding out, oh, that peer was lying to me, I have to go back and search for another block source. So this is a major, major improvement. That's our signature improvement in 0.10. Some other features in the Bitcoin D wallet. This is not a protocol layer thing. This is a Bitcoin D wallet layer feature. Our smart transaction fees. And typically what it does is it looks at the prior history of the Bitcoin blockchain and its own memory pool and examines how fast are blocks with a certain fee confirming, how fast are blocks with a larger fee confirming, et cetera. And it seeks to ascertain the lowest fee that you can pay to get your transaction confirmed instantly. The lowest fee you can pay to get your transaction confirmed within 2 blocks, within 3 blocks, et cetera. And so this is another step towards what we're hoping to see in the future is a dynamic fee market, where it's not just an anti-spam limiting fee, which is traditionally what's been on the Bitcoin network, but more of an active bidding process where you bid for future blockchain space. Another new addition is the HTTP REST query API. And right now it's pretty basic, but the general idea is that it provides unauthenticated access, very similar to some of the new blockchain APIs that are out there. You can have that on your desktop simply by running Bitcoin Core. So this is, as I mentioned, just basic. It has two main queries right now, but the purpose is to introduce the interface and then start adding more functionality. Other changes. The very first bullet point there is a network-wide change once the nodes upgrade, is almost any pay-to-script hash redemption script is accepted. Previously on the network, only the nodes would relay what are called standard scripts. That's a multi-sig, that's a pay to an address, etc. So you are very, very limited in a whitelist type fashion to what could be relayed on the network. And that's quite limiting for the script language that we have. But with pay-to-script hash, you pay to a hash, and then at redemption time, that's when you actually see the script. And this change will relay any of those scripts, enabling much, much wider breadth of features. You can do, for example, an M of N multisig or another key. Or you can have multisig and multisig to enable two groups or three groups. It's really limited by the Bitcoin script language itself. We have watch-only wallets, so you don't have to load the private keys into Bitcoin. You can just use Bitcoin D's transaction monitoring to monitor public keys. A security feature, we have improved signing security. Peter Woolley, one of the core developers, wrote the libsecp 256K1, which is basically a replacement for OpenSSL's elliptic curve cryptography. It's based on what we learned in the past couple weeks. It is our belief that this is actually better reviewed and better tested than OpenSSL itself, because we are in Bitcoin Core using some elliptic curve features that basically no one else uses. And so whenever that changes, that potentially exposes some bugs. And we're sort of the 99% user of that OpenSSL feature. Last week, there was an OpenSSL upgrade that caused a bit of a security alarm because the reliance on OpenSSL implied that some signature checking would change if you upgrade your OpenSSL library. And so all of a sudden, this quote bug fix that was released in OpenSSL could potentially cause hard forks on the Bitcoin network. And so we're switching away from OpenSSL as fast as we can. Another feature that we have introduced in 0.10 is a consensus library. That moves all the consensus critical code into a library that's linkable from C, C++, Python, JavaScript, etc., Node.js. And the point of that is that you isolate all the consensus critical code and then let other projects use it rather than rolling their own. Because we've seen in the history of Bitcoin alternate implementations is typically they're human, they make mistakes. And in the Bitcoin world, when you make a mistake, that potentially introduces risk. For example, there's a rather large Bitcoin website that uses an alternate implementation, and you could, months ago, fork them off the network simply by using a little bit of a strange signature. And that was simply because they wrote their own implementation, and it was incomplete. So anyone, anywhere could just knock that website off the internet, or off the blockchain at least, by creating what everyone else recognizes as a valid signature, but this alternate implementation does not. So the consensus library addresses that issue. And then finally, we're adding some command line utilities to Bitcoin Core, the first of which is something called Bitcoin TX. That allows you to easily create, modify, sign, transactions. You can experiment with custom scripts. It's very flexible. So, moving on to the exciting announcement from BitPay, we have a payment protocol. Not the BIP70 payment protocol, but something based on payment channels. It's called Impulse. And that's the website and the protocol specification. What is the holy grail of Bitcoin? You know, one of the biggest user complaints, of course, is about confirmations, that you have to wait some random, undefined amount of time before your payment is secure and confirmed. So blocks on average take 10 minutes, but statistically they might take 20 minutes, 30 minutes, 40 minutes to confirm a single block's worth of transactions. So the holy grail is an instant secure transaction. Right now we have instant transactions, but at 0 confirmations they're not secure. Now if you use payment channels, a interesting new feature, well, not a new feature, but an interesting feature that involves smart contracts, then potentially we can get very close to that. This is an open protocol. The specification was on the previous slide, and it's based on payment channels. Now, let's review what payment channels are and how they work. Essentially, they're trustless, just like Bitcoin itself, and they operate on a 2 of 2 multisig. So you and the party that you're connecting to or talking to have to both be in agreement in order for payments to proceed. Now, this is a step-by-step of how a payment channel works. This is a bit technical, but this is a tech talk. You exchange public keys, you get an opening BDC value for a payment channel. Now, this is not Impulse. This is just a basic payment channel technology. The customer creates an on-chain payment, but they don't tell it to BitPay. They just send the transaction ID to BitPay, or potentially the canonical transaction ID. The customer creates a time-locked refund and sends that to BitPay. BitPay signs it and returns it. Now remember, BitPay still has not seen that first transaction. Thus, they're guaranteeing that they are not committing funds until they've received a signed refund. Once you receive that signed refund, you guarantee that your funds are not going to be lost if BitPay or your payment processor explodes or runs away. So you send that first transaction out, it commits funds to the blockchain. You now have an open payment channel that's funded with committed funds in the blockchain. Now, the way payment channels work is once you have that payment channel open, funds are committed, you can rapidly revise a payment such that you send, let's say we're paying Lyft. So we create a transaction that pays Lyft 0.1 BDC and pays me 0.9 BDC. And this is off-chain. And then we want to make another payment, let's say to Starbucks. And so we revise that transaction again such that we're paying 0.1 BDC to Lyft, 0.1 BDC to Starbucks, and 0.8 BDC back to myself. And so on and so on. You keep revising this. And then finally, when both parties are ready to commit these off-chain transactions to the blockchain, the final payment is signed by both parties and the funds are committed. Now, that's entirely trustless such that if the customer departs, BitPay still has signed transactions that can publish to the blockchain with the Lyft and Starbucks payments. If BitPay disappears, the customer still has that refund transaction. They haven't lost any funds. And so that's how payment channels are essentially trustless payments. Now, what did we add on to that? Basically, the model is that payment channels, you have multiple payment channels inside a wallet, and we model these as unspent transaction outputs. Let's take the example again of customer pays Lyft 1 BDC. The wallet keeps multiple payment channels open, and then we get that payment information from BitPay or your payment processor or your other party, and the wallet looks in its set of payment channels, says how many of these payment channels total up to 1 BDC or more. Just like the UTXO process, and you send the payment out to those payment channels, and you close it. So what you have is funds are already committed on the blockchain, payment channels are already open, and so when you're ready to make a payment, you can make a payment with instant, already committed funds, where if either you or the other side departs, the payment channel integrity remains. And finally, if obviously, just like you have a change transaction or change address in Bitcoin, you have to do the same with payment channels within Impulse as well. And so fundamentally, you have achieved instant secure transactions, provided that there is one element of trust. The other party, be it BitPay, payment processor, et cetera, is the one you have to trust, that is the one that Lyft has to trust to send the right TX output to the customer. And so with that, you have essentially sort of a instant secure committed funds protocol where the only element of trust is with the third parties being paid if you're a payment processor. And they already trust us anyway to provide proper TX outputs, provide fund addresses. Now, what just happened? We made an instant secure payment. The customer is secured against BitPay stealing funds. Lyft and BitPay are secure against clawback. And interestingly for our business, BitPay does not actually hold funds. The funds, in this example, go straight to Lyft. The caveat, of course, is this is increasing transaction activity on the blockchain. And so you have several more transactions to execute a single payment. But we think that that is mitigated by several things. Your wallet will sort of conduct a defragmentation type process. It'll keep sufficient payment channels open so that you're not creating undue fees or undue transactions. So right now, the protocol specification is published. It's on impulse.is. The basic payment channel work just for core payment channels is going into BitCore, the open source JavaScript library. The Impulse protocol code is under development, and we're publishing it now to really link with other people in the space. There are a lot of people working on payment channels, but it's at the moment quite private, and we really believe that for this technology to succeed, it must be open source, it must be transparent, open specification, and notably, all those lead to it must be implemented in multiple wallets across the ecosystem. So if one wallet or two wallets implements instant secure transactions and the other doesn't, then you're at a disadvantage. Moving on. One of my passion projects is BitSat. I've been working on this since 2011. In the background, it began to pick up speed in 2013. Basically, that's precisely what one of our satellites looks like. We have completed the design. It's, to give you some of the tech specs, it's going to be, inevitably, it's going to be slower than a fiber optic cable running across the terrestrial ground. But you look at CubeSats and you think, okay, we have one of these. That's sort of like a cheap laptop in space. But if you have many in space, you have a peer-to-peer decentralized network. You have a 3U CubeSat. It's, those are the uplinks and downlinks. Your average satellite, whether it's CubeSat or not, you'll have 15 minutes of communication time per pass and 4 to 14 passes per day. That is what the constellation will look like once they're in orbit. That's called a birdcage orbit. You have multiple orbits targeting all of the main continents and geographic zones. Obviously, we don't cover the middle of the Pacific Ocean too well. But 24 satellites should be sufficient to cover, and that's 4 to 6 per orbital plane, to cover all of the continents on Earth and provide Bitcoin blockchain access. Now, just our quick status is we're designing and going to operate the BitSat. Annoyingly, this technology is covered by export controls, so we have to get reviews by the State Department and Commerce Department before we can publish the design publicly. And we're currently, this month in fact, going into our first seed round, which is very exciting. So those are the three things that we're looking at today in BitPay and Dunvegan space. It is an exciting time for Bitcoin, and it's an exciting time in payments. And I thank you all for listening.